Hello, ladies and gentlemen. Let's discuss water a little bit here. So we're going to start with chapter 13 on water resources, and then we'll move on to water pollution in our next chapter. This one's fairly long, so there'll be several videos. Here's the first section. Do we have enough usable water? Is there enough on the planet? So let's get into that a little bit. So here's a breakdown of all your water on the planet. That's the bubble illustrated right at the top. Of course, fresh water is that little thing, and then that little tiny dot right down there. That is how much we actually have available for us to use. And let's get into why that is. So if you look at water on the planet, 98% of that water is salt water. So it's not in a usable form for us currently. Yes, the vast majority of that, of course, is in the ocean. It leaves us this 2% sliver. This 2% sliver is 87% frozen. It's in glaciers, polar ice caps, things like that. So most of that 2% is not available to us. Of that 2% that is available to us, 12% comes from groundwater, and only 1% comes from lakes and rivers. And so you see the stuff that's easily accessible to us is 1% of 2% of all the water on the planet. We're talking very small quantities. And so when we're talking about that's easily accessible, and then if not, we have to pump underground to get the rest of it. And so it's not easily accessible for people, and if we pollute this small portion that we have here, this small little chunk of pie that we have from this big chunk of pie up here, we are going to have ourselves a little bit of trouble. And so accessing water is a big issue, and it's an issue on lots of levels. It's a health issue. If you remember when we went through the biological hazards and what caused death in most people, it was things like cholera and dysentery and things like that. It is the single largest cause of illness on the planet is the lack of clean drinking water. So it's a health issue. Next, it's an economic issue. It is absolutely vital for people to have water to sustain food, to produce energy, to grow crops, all of that stuff. So it is the benchmark. Agriculture is the benchmark of the economic system for people. And so it is where we start, and without it, things fall apart fast. So it's an economic issue. It's a women and children issue. A lot of times in poor countries where water is not currently available, that is the job of poor children or women. They do the daily chores of collecting water. Here's a picture of it. They can walk miles in some cases to get fresh water, daily, collecting as much water as they may need. And so as a result, that's less access to do all the other things in the world, get themselves a job, gain independence, get an education. And so issues within that. It is a global security issue. There have been many wars fought over water and the limited supplies of water. And so it is an issue for security. And of course, it's an environmental issue, because when we have water issues, we have, if we suck too much water out of the rivers or groundwater, we can have pollution issues. We can have shrinking amounts of fresh water on land. We can lose wetlands. We can cause fish populations to mess up. We can reduce water quality. Ecological services that the aqua systems provide us, all of those things are tied to water, and they're all environmental based stuff. So you see water touches many different things in the world. Here's the water cycle. Won't get into detail with it because you guys have already seen it. We know there's evaporation that turns into clouds and condensation, and then eventually that causes precipitation. And then that runs off into the ocean. It can start all over again, right? Or it can infiltrate down into the groundwater, and that groundwater can actually flow out and into river systems, or it can stay in the ground until we get it out. Some terms that are going to come up over and over again here is surface runoff. Absolutely, that's going to show up a lot. Evaporation is, of course, a common term for you, but evapotranspiration or transpiration from plants are important terms for you. Sublimation is where frozen water on mountaintops turns directly into gas and goes back in the atmosphere. So this is the water cycle in a nutshell for you. We'll get into it more and more as we go. So with that comes some terms that you need to know. Surface water. What is surface water? Well, it's anything that's in a river, stream, pond, lake, wetland. That's what we consider surface water. Pretty straightforward. Groundwater It's stuff that's underground. So it's precipitation that's infiltrated or went down into the ground and is stored in rocks and soil down there. When we talk about groundwater, a lot of times we talk about the very top portion of the groundwater that we pay attention to, which is called the water table. That is the one that we usually engage with wells and stuff. We pull water from the water table. Next, surface runoff, like I just talked about earlier. This is water that does not soak into the earth, but then runs across the top of it and gets into bodies of water, lakes, ponds, rivers, streams, ocean. Well, not ocean. Ocean stops running off. It just sits there, but nonetheless. And then a term that might be new to you, may hopefully not be new to you, is watershed, sometimes referred to as a drainage basin. So this is the whole section of land in which water drains to a single location or a point. And so when we look at, say, what that is if you look at a river system, if any rain falls within this red line here, it will all eventually get into creeks, streams, whatever, and work its way down into this river. So we would consider this a watershed or drainage basin for this river system. And so if you look across the United States, these are the major watersheds or river basins. And so we are a part of this blue one, which is the Missouri River watershed. All of the water from our area that eventually gets into the Tongue River, the Powder River, those kind of things, eventually goes into the Yellowstone, which then goes down into the Missouri River, which eventually goes into the Mississippi. But we are part of the Missouri watershed. So that's actually illustrated over here with some of the other major watersheds. And then eventually it dumps out into the Gulf of Mexico. Here is the breakdown in Wyoming specifically of the different watersheds here. So you see that some of the water doesn't go to the Mississippi. The Green River Basin, the Snake River Basin, these ones over here on this side of the state all actually shed this way. See, they're part of this watershed here, and they all actually go out into the Gulf of California. And so these head west. All of these ones up here, the Bighorn River Basin and Wind River Basins, the Northeast River Basin, the Platte River Basin, and then the one we belong to right here, which is called the Powder Tongue River Basin, we all flow the other direction. Now, the Platte flows down into Nebraska, but we flow up into Montana and then work our way into the Missouri and the Yellowstone. And so that's the breakdown of the river basins here in Wyoming. Next, aquifers. Aquifers are basically huge pools of underground, they're not pools really, they're huge amounts of water underground that's stored within rock layers, basically soaked into the rocks. And this can happen in a couple different ways, but a lot of times it's sandy layers and gravel underneath the ground. Most of the aquifers that we have in Wyoming here are part of a sandy gravel rock layer. We can also have sandstone and limestone or even fractured igneous rocks from lava rocks that can hold water, but the main ones are sand and gravel. And then there's two kinds of aquifers. There's renewable and non-renewable, and they are exactly what you'd imply they would be. Renewable aquifers are ones that can be recharged. So natural recharge is where it rains and that water soaks back into the earth and then recharges or refills those underground lakes, basically. And then there's lateral recharge, which is where a river that's flowing by will have like seepage out of the river and into the aquifer. So both of those are ways to recharge it. Non-renewable aquifers are usually really, really deep underground, and they don't recharge at all, or they do just a little teeny tiny bit. And so these ones are, if we're sucking out of these ones, we have bigger issues because they don't fill themselves back up. They're a non-renewable source. Here's a breakdown of where the aquifers are in the United States. So you can see they're pretty much everywhere, and there's different ones in different ways. I'll make point of this one right here first, this one that stretches all the way down into Texas and up into Nebraska. This is the Ogallala Aquifer. It is the largest aquifer in the world that we know of. It is huge, and it feeds water to most of the Midwest, and so it's a pretty crucial water source in the United States. We're part of this aquifer up here. You see all of this section right here is what we're part of. This is rich in sand that I was talking about earlier. It's a large aquifer as well. So with aquifers, there's also two kinds of them. There's unconfined aquifers and confined aquifers. Confined are exactly what you'd imply them to be. They're confined, which means there's not really an outlet. They're in between impermeable rock layers, so water can't seep down into them very easily. They're usually charged on the tops of mountains, and that water is down underground, trapped. So the only way to get through it is to drill underneath all of that stuff. That water's usually been down there for a very long time. Unconfined aquifers are aquifers that interact with the water table, which is right here. And so we can have infiltration directly into it. These aquifers can bleed out into lakes, and so they can feed the lake from underneath, keeping it full. Rivers can feed into it, feeding it. So it's more interactive, the unconfined one is. All right, moving on. I'm going to go a couple more. I'll probably have to split section 1 up because this is a pretty long section. So, large and growing portions of water that we're using and what we're using it for. So, when we talk about water usage on the surface of the planet, 2/3 of that surface runoff is lost in the form of flooding, typically. Okay, 1/3 of it is what we call reliable surface runoff, which means we know we can use it. It's a source of fresh water. We can count on it year after year after year. So it's about 33% of the runoff we can trust that is available for us. We currently use about 34% of the world's surface water, but depending on the situation, up by 2025, we assume that we're going to be using about 70% of it. A large quantity shift, scary number difference. What are the uses for water from these sources? Well, vast majority of it's used for agriculture, mainly irrigation for agriculture, which is 70% of it. 20% of it goes to industrial use. So 90% of the water on the surface really gets used, not in your house, but either for growing your food or creating your stuff. And then domestic use in cities and homes accounts for only 10%. It's about 10%. 1 out of every 10 gallons is used in people's homes. So we're going to continue on with this section. We'll break it into 2 pieces for you.